So moving into 6.4, it may help to think back to some of the basic things that are going in with what we're looking at here. That is, when we're talking about a graph, we're just talking about a pictographical representation of our equation. That is, the graph consists of all points that satisfy the equality or function or what have you that we're looking at, where that may be in rectangular coordinates, something like a cubic or a linear function or a root or a square, what have you. That's the sort of thing we're doing with graphing of our equations, and when we're doing this with polar equations, it works in much the same way, except because things are polar, they're a bit more circular, so we talk about our graphs in terms of a thing called a polar grid sometimes, just to make sure we're clear on that sort of circularity. But here we're going to be looking at just a couple of patterns that we get with our polar equations, where the first one is the most basic one, that is a circle, where we have two ways that we can get circles in the polar plane. We can either have things of form r equals a cosine theta, in which case we have circles along the x-axis, and then things of form r equals a sine theta, which are along the y-axis. And to understand this, to understand how these types of problems work, we're going to take a shot at an example. So for this example, we want to graph the equation r equals 4 sine of theta, where to do this, we're going to be careful here. We're going to go through piece by piece, and we're going to take each thing kind of in terms of basic values, where thinking back to what we saw earlier on in trig, when we're looking at trig functions like sine and cosine, a lot of important behavior happens at multiples of pi over 6. Pi over 6, 2 pi over 6, or if you prefer, pi over 3, 3 pi over 6, which is also pi over 2, pi halves, and so on along the unit circle. Most of the basic values that we have happen to be at pi's over 6. There's some stuff at pi's over 4, but we're going to stick to those ones because they make nice, consistent gaps that we can work with. So, if you want to work with this, what we're going to do is just go through point by point until we make a full revolution, knowing that we're going to end up with a circle here. So, at the value at the value theta equals 0, that is, when our angle is 0, we would have 4 times sine of 0 or 0, so we would end up at the origin there, at the polar axis, at the pole, as it were. Then at our first pi over 6, what's going to happen is we will have 4 times 1/2, or 2, which will give us a radius of 2 at an angle of pi over 2, which is going to be an increasing value coming around. So we'll come up and around just a little bit. And then at pi over 3, remember that sine at pi over 3 is root 3 over 2. So we're going to get 4 times root 3 over 2, or 2 root 3, as it were, which is about 3.5. So we're just going to keep coming around the outside there of that circle, and then we're going to keep on going through to pi over 2, where at that you get the value 1 for sine, so you get the full radius value there, the full diameter actually, of 4. That is, at that value you will have r equals 4 and theta equals pi over 2. Meanwhile, keeping this rotation going along to 2 pi over 3, that is our next multiple of pi over 6. We're going to just keep coming back around, but now our angle is going to start pulling back down towards the axis, so we're going to have a radius of about 3.5 again, that is 4 root 3, and then we're going to have 4 times 1/2 at 5 pi over 6, and finally we're going to be back at 0 at pi, so we will have completed our full rotation of the circle there, and to get that polar grid shape back, we'll end up with something like this that we can see, Or the other way we can understand that this is what we should get, that we should get a circle like this, is thinking back in terms of rectangular coordinates. That is, if we have the equation r equals 4 sine of theta, we can multiply both sides by r, get r squared equals 4r sine theta. R squared is equal to x squared plus y squared, and 4r sine of theta is going to be equal to 4y. Then we subtract over that 4y and are going to complete the square. We'll have x squared plus y squared minus 4y equals 0, or x squared plus y squared minus 4y plus 4 equals 4. And pull out our square there to get x squared plus y minus 2 squared is equal to 4. So we can see that this is a circle of radius 2 centered at the point 0, 2 based on this pattern in rectangular coordinates. But we should also see here that thinking about what happened when we were graphing that, as we got along up to that top side, that is when we got back to the y-axis, when we finished our graph, it was just reflected over that. So it may have been more efficient to have made some sort of recognition there that the symmetry should have happened and we really only needed that first half. We only needed to get up to pi over 2. And we're going to see in our next video how we can make that kind of determination, how we can recognize symmetries to make our graphing process a bit more efficient.